through it again if it's terrible. And we're going to talk now briefly about variance inflation factor. We'll see VIF in future. Second, here we go. All right, so this is the second part of CS 746 lecture for February 12th. And we're going to talk about what the variance inflation factor is in brief. We'll see this in future lectures. We haven't got to that lecture yet, but I've got a number as part of this to understand what correlation, strong correlation can do. We're going to use multiple linear regression in our next couple lectures. We're going to show you how to, draw that line that best predicts the target. It uses independent variables, free predictor feature variables to predict a single dependent or target variable. In the iris data set, we're going to use the petal length width, sepal length width to predict what the species is. We're going to see whether our predictions are in line with the categorization that Fisher and Aylward did back in 1936, right? This assumes that features are independent of each other. If the features are not independent, and true independence is basically impossible, right? Everything has some variant or some covariance in common. But things that vary very closely together are called collinear. So if there's no variance at all between two things, right, then they don't add separate information. Their values are strongly correlated, whether it's a positive correlation or a negative correlation, strong collinearity, right? VIF is a metric that we use to measure collinearity. And so basically, I'm just going to talk about, imagine we're building a multiple linear regression model, right? We want to include the most useful features. Those are generally the ones that most strongly predict the target, the ones that have low collinearity with other features, and the ones that, when they are excluded from the model, significantly worsen it. We want to exclude the useless features, features that don't change much, features that don't correlate at all with the target, features that are strongly correlated with each other, and the ones that, if we exclude them from the model, our model doesn't change much. And so we're going to use, we had 4 feature variables to see if we could predict species. We generated pair plots, scatter plots, correlation table, and a heat map to compare every pair of features. So sepal width times sepal length is weak negative correlation. Petal width times petal length is strong positive correlation. Sepal width and petal length is a moderate negative correlation, so on and so forth. We can just characterize those by looking at the graphs, and so on and so forth. Wouldn't it be great if we had a metric that we could use to measure everything all at once? And the answer is yes, it would be great. That's called the variance inflation factor. It is a metric for measuring multicollinearity. Given n features, we calculate a linear regression for each feature using the remaining features. And we'll see that in the future. We use some metric, and we do this calculation here. We get what we call the VIF, and that tells us how well feature sepal width is predicted by the other features of the flower, right? So you can predict anything as your target. You have a goal that you can assign to for your task, but you can look at the predictions of how well each feature is predicted by the other features. And when you see something that has a VIF of 1, this equates, and we'll see this again in the future. I maybe shouldn't have pulled this in just yet. Anyhow, this equates to an R squared of 0. There's excellent zero collinearity, also impossible in real life. VIF between 1 and 5, or the R squared between 0 and 0 to 0.8. That's pretty good, low to moderate collinearity. And again, R squared is saying how good a predictor are these features of our target. So when we have a high R squared that says the other features are really good at predicting this particular target, our variance inflation factor comes out between 5 and 10. We say this is a high correlation, we may want to exclude it. If we see a variance inflation factor of bigger than 10, basically this is nasty. This variable is useless. If we put this into our model, it will increase the variance. It will cause all sorts of, undesired effects. Let's throw this variable away, get rid of it. So you want to start looking at that. We're not going to do that just yet, but it seemed like a reasonable place to put it because I had the time. So, all right. That's our lecture. Do we have any questions at this point about what I've just talked about? Stop recording.